Recording. Welcome everyone to the December Solarchat Zoom meeting. Thank you all for being part of our group. And there's some more people coming in. Good, we're having a good turnout. First off, happy holidays to everybody, and thank you so much for making our forum the best astronomy forum on the internet. I appreciate it. We have the best information. We have zero arguments, and I really like it. And we've been around now for almost 14 years. And once we got rid of Apollo Lasky, everything has been working perfectly. So there's Rainier and Ivan and Steve. Okay, I'm going to mute myself because of the dog, but I just wanted to tell everybody how important you are to me, and I'm really grateful for the forum. And remember, our goal is to have a resource on the internet where the best information for solar imaging and solar astronomy lives, and be very welcoming to people, and to encourage everybody who will listen to us to get involved in this hobby because it's awesome, and to do all this in a friendly manner. So I appreciate that. Alexandra, would you mind taking over and introducing our speaker while I mute myself?
Okay.
There we
We
go.
can't hear the dog, Stephen.
What's
Hello.
that?
We can't hear the dog.
Oh, well, okay. Alexandra's got a better accent anyway, and she sounds more intelligent to me. So I'm going to be quiet and enjoy the marsh and watch the show.
Is George on the line? I can't
Yes.
see.
Yes.
Oh, that's good. That's great. Oh, hello, George. It's nice to see you for the first time.
Yes, that's right.
I think it's absolutely wonderful that you've come onto this special. So it's like the Christmas lecture to tell us all about the coronagraph, because virtually, I think you're probably about one of two people that actually does amateur looking at the corona. So I think that it's just absolutely fantastic what you do, and we'd all love to hear all about exactly how you've made it, how you process the images, how you see everything about it. It's absolutely fantastic. So I'll let you talk from now on. Okay, thank you very much.
Thank you, Alexandra, and it's an honor to be asked to give the talk. Thank you so much. Let me try to share my screen. That may have just worked. That would be good.
Yeah, it's fine, George.
Okay, you've got the right one? The correct image? Good. So, hi there, that's my name. My club is mainly Amateur Astronomers Association of New York. I live in Manhattan, in New York. First, some acknowledgement. My coronagraph was built in collaboration with Klaus Hartkorn. Klaus may or may be on yet. He was going to join today. I consider him to be the inventor of the amateur version of the coronagraph, and he's the first one we know of that viewed an image of the corona. That was November 2020. Also, just pointing out Christian Villagerich's solar astronomy book, with the subsection actually written by Klaus about it, so you can gain more information there. Okay. So the corona is really three coronas, probably more, but three I can talk about. One is the K corona. That's what we usually think of when we go to a total solar eclipse. It's the thing that's closest to the sun with the pretty streamers. And that's light scattered by free electrons in the million-degree solar corona. It happens to be polarized, which sometimes helps us. The E corona is very similar to that. It's light emitted in narrow spectral lines by things like iron-14, so iron without 13 electrons, again, that million-degree atmosphere. And so it emits in green and red and some other lights. I'll talk a little bit, it's much dimmer, like 100 times dimmer than the reason the total eclipse is not green or reddish green is because it's 100 times dimmer than the white light from the K corona. And last is the F corona. That's the corona as you go further out during a total eclipse, and it's a continuation of zodiacal light, or however you say that word. So that's predominant beyond, say, 4 solar radii. So here's a graph of the brightness of each of these things along with the sky brightness. So prominences, so solar prominences, the chromosphere, are like, now the reference point is the photosphere. So a prominence is like 1,000 to 10,000 times dimmer than the photosphere. The K corona is just short of 1,000,000 times dimmer than the photosphere. The F corona further out we won't worry about, but the E corona, that's like 10 to 30 million times dimmer than the photosphere. And that's the thing we're trying to see in the telescope. I'll show you in a moment. So you have something that's a certain brightness, and an arc minute away from that, you're trying to see something 30 million times dimmer. That's the challenge. This is just another graph. That's interesting. They put the full moon at 10 to full moon as dim as the corona, whereas I can see the full moon on a regular day. So I'm not sure. That may just because it's so close to the sun. I have to revisit that one. So prominences being 1,000 times dimmer than the photosphere, or a little dimmer. It comes in narrow lines, but has a huge advantage. The prominences are blocked by the chromosphere. If you can get a narrow band filter there, you can see the prominences even better because the photosphere is actually being blocked, versus the corona, which is, say, 4 millionths of the photosphere, so much dimmer, or 10 million times dimmer than the photosphere. But the corona does not block the photosphere. So no matter how narrow you get, you still got to contend with the native light at that same wavelength. So you don't get that benefit that you would get from the chromosphere. It's a big challenge. If you're used to doing double stars, Rigel is very easy compared to this. Sirius is easy compared to what we're trying to do here. So Bernard Leo invented the coronagraph in the 1930s, creating an artificial eclipse, which was the easy part. So putting a cone or something, an occulting disk, at the focus of your telescope to block the photosphere, and then look around that cone for the corona. The hard part was eliminating all the internal sources of scattered light, and everyone told him it was impossible at the time. So the first thing you got to do, I'll get to the atmosphere in a little bit. In your telescope itself, each glass surface scatters light. So you tend to use a singlet lens, so that reduces the number of surfaces. And you certainly don't want cement or other things that can reflect. You don't want a coating. You would think you want a good coating, right? Because you want to reduce scattered light, but actually the coating increases scatter, it reduces reflection. What Leo did was he invented a way to get rid of the reflection, and therefore went for an uncoated lens, which had lower scatter. And you have to do it highly polished. I bought my lens after signing a bunch of documents promising never to export it outside of the US. I bought a 10.5 scratch dig high power laser lens. And so that's what I use. And it's scratch dig, like how rough is the surface? And it's many times better than, say, a high quality astronomical lens, which would be 60-40. Of course, Leo didn't have that, so he used nose wax on a lens he ground himself. So he spent a lot of time grinding the lens perfectly, scratched the side of his nose, and then rubbed it on the lens, and achieved what I'm achieving by signing a bunch of papers and getting a laser lens. Next thing that goes wrong is that the light gets diffracted around the edge of your objective lens. Leo invented what he thought of as, well, that diffracted light is not scatter, it's not random, it's coming in coherently, semi-coherently. Behind the cone, he puts a field lens, which then focuses that diffracted light into a ring, and then he puts a stop there to block that diffracted ring. It vignettes your lens, so if you start with 50 millimeters, you end up with 40 millimeters, more or less, but it gets rid of all that light, and that's a big effect. One that's a little bit controversial, but I think I proved is important, is reflection within the objective lens. That is, light comes in, hits the back of the lens, then hits the front of the lens, and then goes back towards your eyepiece. And it causes something that looks like a piece of dust in the middle of the lens. Calculations show it shouldn't be that bad. Leo stopped it, but I'll show you the setup I used to prove that it actually is important. So I have something called the Leo spot at back. You'll see it in the design in a minute. And then dust. So like for every hour you spend building this thing, an hour is spent taking the dust off it. I'll show you what I do for dust in a little bit. It's quite crazy. Then you have to block the photosphere with this cone, right? So that cone, what Leo did is he put a disc there that's the artificial eclipse. Then he put a hole out the side for the light to escape the scope. But then that hole had a glass thing on it. So you had a hole for the hole. So when it reflected off his glass, it would actually reflect out another hole in the telescope. So he had an elaborate system to exhaust the heat. For me, I literally just spread the light around the inside of a tube that you'll see in a little while, and against black that's less than 1% reflective. I'll get to that also. And then a field stop to block the light from going further down. So I don't exhaust it out the side. I just dampen it with very black paint. Actually, Musso Black is the one shown right there. Musso Black's below 1%. You go to the store and buy like Krylon Black, some hardware store, very super black paint. That's like 5% reflection. It's very higher than you'd think. And with Culture Hustle Black 3.0 from UK, you can get down to 1 to 2%, but Musso Black from Japan gets you down to about 1%. You remove all the baffles from your optical tube. The last thing you want is light coming in the objective, hitting your cone, bouncing back up your telescope, hitting the back of a baffle, and coming back down into your eyepiece. Any light that comes off your cone and starts heading up into the sky, you want it to keep going into the sky. You don't have the sun sitting off center. If it's off center, then it's not behind the cone. So you don't have to worry about normal baffling that you would do in a telescope. Your baffle is the cone. That's going to be right at the right place. You don't need to do anything else for that. So you remove the baffles to reduce scattered light. And then you do a million other little things that's why it takes a year to build this thing. I'm targeting the E corona. It's dim, but I can improve my signal to noise ratio by about a factor of 30, believe it or not. I have a 1.2 angstrom double stack filter. So it's basically it acts as a 2-cavity filter at 5303 angstroms, which is iron 14, as I mentioned before. Klaus and I went to Andover Corporation and ordered them custom made, which is how we got there. They're each 2 angstroms, and we put 2 of them, and that double stacks to 1.2 angstroms. Excuse me. I need to keep it at 32 degrees Celsius. So I'll show you that's the oven shown in the picture. That's the inside of the oven. What you see there is the inner barrel is what holds my filters. They're 25 millimeter filters. And the outer barrel, you'll see in a little bit, holds some heaters. And inside I have some thermistors, 2 thermistors and 2 controllers. And that's how I keep it at 32 degrees. That cost me like $25 in parts from Amazon and like many hours of work to then turn that into an oven. So you take the filter and stick it in a telecentric beam. I'll show you that in a moment, so that you don't get a sweet spot. You just get a little bit of widening, but I'm working at effectively F30 by that point. So my first foray, I had bought a Botter prominence viewer, if you remember them, from the 1990s. I bought it used for $400. The H-alpha filter was shot, which I knew, and I figured I could fix that. What I didn't know is that the field lens was defective also, and my seller didn't know because he bought it not knowing it was a mess. So there's like a lot of work to do. It came with a Celestron First Scope 80. I used it over the summer, and I was going to use fancy image processing to get the corona. I quickly knew that was going to be impossible. And so I was still thinking what to do. Then in November, Klaus Hartkorn posted that he saw the corona. So we started talking, and pretty soon we had thousands of messages back and forth between us on how to build a coronagraph. So after about a year, I had turned this Botter prominence viewer into an actual, like I know it's called a coronagraph, but actually a coronagraph that looks at the corona. It took me about a year to do it, but it had some aberrations. You'll see the result in a little bit. So then a year later, I started from scratch. I basically from scratch, other than reusing the cones, because it was not, those are rhodium plated and pretty nice. So I reused them. It took me another year to build and test a new version. So I'll show you that. And I have it right here to show you in person. Atmospheric scatter, like in the textbooks, it says you have to get high to see it. You have to get above atmospheric scatter. I'll show you evidence to the contrary. But so I view from a mountain in New York. It's about 3 hours north of me at 3,200 feet. What's special about that mountain is there's a road to the top and a lot of space to put a coronagraph and a bathroom there too, by the way. Whereas like Hunter Mountain, which is closer to me, is much taller, but I can't hike up with my coronagraph. Klaus uses Mount Mitchell, which is 6,600 feet, the tallest mountain on the east side of the U.S. But lately, I've been able to image from Cherry Springs State Park in Pennsylvania. That's where a lot of the star parties in the U.S. are, the Eastern Star Parties. So I can go to a star party location and do it. It's a little bit of a timeline. Klaus, as far as we know, is the first amateur to view and image the corona on November 16th, 2020. I became the second on September 11th, 2021. And then Christian Beal used a spectrograph and processing to detect it. He didn't see it and didn't take a traditional image, but he did definitely detect it on March 10th, 2021. And then Jim Daly became the third person to actually image the e-corona in the traditional way. He did it at iron 10 instead of iron 14, which is red light. He did that just this last September. He couldn't see it, but he could image it. I already mentioned Christian's book. And then to mention, but there have been professional chronographs around for the last 100 years, thanks to Leo. So the Solar Dynamics spacecraft is what I usually use, and that's a satellite in far UV. So 210 angstroms is the closest match to 5303 angstroms. You can also look at 193 and 171, but 211, there was actually a study and they proved that that had the highest correlation. And there's also SOHO and stereo. If stereo stays in existence any longer, things keep breaking down from it. A beautiful coronagraph on Mauna Loa in Hawaii is the Cosmo K coronagraph. So that's a good one. And that's 200 millimeters. And then Lijiang Observatory coronagraph at 10,000 feet in Asia is 100 millimeter Leo coronagraph. I'll show you that. I don't know. My pictures look a lot better than theirs, but they're doing science, so they can't do the image processing I'm allowed to do. Like they can't cheat and change an intensity or something, or they can't tweak the contrast. So I think that's why I think they could do better if they were allowed to do that. So the objective focuses the sun on the cone. That blocks the photosphere. You block the scattered light from the cone with the field stop. Then you have a field lens that focuses objective scatter at a Leo stop and spot. That's, as I already explained, the light that's diffracted and reflected. Then you have a pair of relay lenses that the first one creates the collimated beam and the second one creates the telecentric beam, and that's for your filter. And then I have my filter, which blocks out most of the scattered light. That is, basically, you can look at it as 1.2 angstroms over 3,000 angstroms in the visual spectrum. So it's like a 3,000 improvement, but the corona is 100 times dimmer, so that's your 30 times signal-to-noise ratio improvement. This is me designing my coronagraph and this is how I work, and there's a lot of scratch outs and messes. I swear I've tried to get ray trace algorithms to work on my computer. I just can't. I tried the free ones. I borrowed, I just can't. So I just go, it's a big piece of paper larger than a sheet and a ruler and a lot of time to trace out my optics. This is just making sure my telecentric was going to work the way I hoped. Here's my optical design, which is actually, and by the way, obviously on Solarchat, I posted a 5,000 or almost 5,000 word description and all the pictures, including this table. But on the left column is the distance I calculated. The right column is the distance I measured. I'm using a thin lens form, or Klaus more than me used the thin lens formula. So, they're not going to be exact. These things are 10 millimeters thick. I don't think, is there anything special to show here? I think I've described it. It's a 50 millimeter uncoated singlet. Then my cone is 9.2 millimeters in diameter. Then my knife edge field stop. Then my field lens, 100 millimeter focal length. Then my knife edge Leo stop. And then a dot, a 0.4 millimeter dot. I'll talk about that in a minute. Then my two relay lenses. And then a couple of UV IR block filters, which are really there to hold the heat in the oven. And then my actual filters there, the 5303s. And then either a Plossl or my camera. Here's the oven. There's my very expertly drawn schematic of my oven and the oven on the right. And it does a good job. Hysteresis is your bane in these things. So you have to figure out how to set the parameters on these two controllers with their two thermistors and two heaters so that it hits the temperature and doesn't oscillate up and down. And so it took a little bit, but I got it right. And now it works very well. It's up to 20. I can do 5, 10, or 20 watts of current. There I am putting it together and testing it. These are my calculations to say, will this work from a filter point of view? Will the light from this telecentric be too tilted and send it off band, or will I remain on band? And so basically it's just going to, Wikipedia, finding the formulas, putting them all together, and then calculating the effect of the tilt. Early on, Klaus and I were considering tilting the filter as a way of tuning it, and we got rid of that, but this formula was helpful for the tilt problem. This is my machine shop, just so if you want to build one of things, like Klaus has like a lathe and a mill, but I've got like a hammer and a pair of pliers in an apartment. So you can build something this complex that eliminates 10 million times the light, get it down to 99 point, I can't even do it on my fingers, 99999% of the light, using a big file and a chisel and stuff like that. So it was hard. How do you drill a hole with this tools? You drill 20 holes and you pick one that looks circular instead of all the rest that your hand drill wasn't so good on. Here's how you mount. So how do you mount that cone? People used to drill a hole in a lens and that was like hopeless. But Klaus pointed out to me that JB Weld is good for 550 degrees. It's an epoxy that you mix and it's super strong. Once you get the bond right, you'll break the glass before you break the JB Weld bond. So this is a 3 millimeter screw that goes into my botter cone, and I need to get it perfectly perpendicular. So I made a jig out of wood shown on the left there with the screw down in a hole that I drilled, and the thing held by all those screws that, as you can see, I can turn them with a Phillips head and make it so it's exactly, within 1/10 of a millimeter perpendicular. Here's another jig. This was to set up a different perpendicular part. And then I have my Leo stop, which is that usually in the botter prominence viewer, I pulled this out, but it was an iris. You need about 4 millimeters. So these are 4.2 millimeter holes. The one on the far left was, let me just see what I can do. Black piece of construction paper with a 4 millimeter hole. You use that. What goes wrong when you use black construction paper in your solar telescope? Well, you can see that arrow there, that light brown. So it does start burning. So then I moved over to aluminum that I got from a hobby supply store, drilled that. That's the 20 holes I drilled to pick the round one. And then I shoved it in the botter prominence viewer with that little like collar that I show you that looks like a crown with that hole that I can move around it so I could align it. So it was very Rube Goldberg kind of telescope, if you know what Rube Goldberg is. Here's my Leo stop and spot. So on the left, you see, this is before I painted it, but before I painted it, you see the silver with a hole in it. And in the middle of that is a little black dot. If you can see that on your screen, tiny black dot. That's a 0.4 millimeter hole that has to be aligned within 0.1 or 0.2 millimeters with the whole axis. Painting that turned out to be harder than I would have guessed. I designed my optics so that the first relay lens coincided with the Leo spot. So that way I could just paint it on the lens and not add one more optical surface that I had to worry about. 0.4 millimeter worth of paint dries in about 1/3 of a second. So how do you paint the thing? Because you can't like dip it in the paint and then go. So what you do is you take a toothpick, which has a much bigger drop, and you hold that with a big drop right next to your lens. First of all, you go in your bathroom and turn on the hot shower for 15 minutes. So now you're saturated, and this is water-based paint. So you're saturated with water, so it dries a little slower. And then you take a single bristle and you just go dot, 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 dot. And you do that like 5 times, and one of those times you'll get a round dot just like that. On the right, you see that thing pulled out, that silver thing, and I epoxied 2 screws to it from a watch screws, so that I could move the thing because I have to get everything aligned perfectly. Here's the coronagraph workings. Going from far right, so going the opposite, far right, front row. There you see the cone silver roundish thing, and then the field stop is right behind it, that 19 millimeter, and that's mounted on a screw that's on top of my field lens. And then there's a spacer right behind it. Then go next to the left. You see now painted black is my Leo stop and spot. And then and my relay lens behind that is more spacers. Come forward again. You see my second relay lens followed by more spacers. No, well, I got the spacers wrong. I'm sorry. Each of those spacers is one in front. It goes spacer, then cone, then spacer, then stop, then spacer, then relay lens. And then it goes to my, that's my oven with my filters in it, and that's just the old XY shifter that I got from the bottle that I don't use anymore, so don't worry about that. Here it is assembled. I'll take it out later when I take off the slides, but that's the workings of the thing. Here it is with my ZWO 1600 Pro camera attached to the back of the oven. So my OTA, my optical tube is a Celestron 8090. It's a 910 millimeter scope, but I have a 1,000 millimeter lens. So I use the dew cap as part of the OTA, and I attach something from Thor Labs to hold my objective to the dew cap. So that's how I got to 1,000 millimeters. Remember, I took all the baffles out of this thing. Here's a picture of the assembled thing. What you see in the top of the picture, in the front is a dew cap that keeps dust off the objective lens. Then that OTA with silver around it, which is probably a mistake because it probably holds heat in. I should probably take off the silver and let heat escape more easily. Anyway, then I get back to the workings that you've seen, including a wire that goes to my oven. Here it is in my apartment, looking out the window. You don't get it. I can look at prominences out my window. I don't normally get the corona out my apartment window. I was mainly just testing it out here. Here I am on Utziantha Mountain, set up on my astrophysics pier. It's nice to have a heavy duty pier because then the sun doesn't keep peeking around the cone. Like you can get if you get it aligned with the North Pole through daytime alignment, then you have like a good run of looking through it. Excuse me. So what do you spend a year doing? Part of it is like iterating on the design. So this is a picture of a cardboard box painted black on the inside. It's way overexposed, which is why my apartment looks white on the outside. And that's an LED flashlight in the middle with a collimation lens and sitting on a black t-shirt or something. Basically, if I turn on a super bright flashlight with a collimating lens, the ratio of the LED to the black cardboard blocks, which is basically set up as a light trap, is about 1,000,000 to 1, which just happens to be the ratio of the sun photosphere to the sky. So I can actually do nighttime testing, look through the scope and not blind myself. Although you don't really want to look at a bright LED for too long. It's better than looking at the sun. Here's me trying to diagnose what the heck's going on. You'll notice that there's a ring in the middle, and that's, well, don't worry with it. And then there's like a little side ring at 4 o'clock. That's the defect in the field lens that I didn't know when I paid $400 for the scope, for the prominence viewer. And then the thing on the left, oh, that bright circle on the bottom, the bright white circle in the middle image, that's the one I was trying to figure out. Where's that coming from and where is it going? Why is it there? Did I do something wrong? So it's a lot of time spent trying to figure out what the heck's going on in this thing. You align the scope. I went to the art store, got a grid, put it in, mounted it in an objective cell, and I replaced my objective lens with this to align the thing to within 0.1, literally like you have to get it right within 0.2, no more than 0.2 millimeters is probably too much, but 0.1 is good enough. Here, so remember I have the stop and the spot shown here on the left, and you see like a little white in the middle. Now, on the right image, I'm looking at that at night through my diagnostic thing. And what I'm seeing on there, I see a bright thing at 11 o'clock, right? A bright light. That's the thing I was trying to figure out what's going wrong here. Let me not go into too much detail about that. But then you see all the little dots, all the white dots, which look pretty bright. They're actually pretty good. I can ignore those. Those are due to microscopic dust on the objective lens. So if the dust is actually microscopic, it's a very sensitive thing. So I can detect microscopic dust on it. I can find the dust if I have a pure black, like a Musso black background with an ultra bright flashlight where the light is shining away, but it goes through the lens. And then I can see the reflection of that light against the black. And that's the only way I can detect that. And that shows up here. If you have like a real problem, it shows up as a very bright thing, like that thing at 11 o'clock. So that could be like a big piece of dust or something. Here's how you clean dust. So I have 1, 2, 3, 4, 5, 6 solutions shown there to get rid of dust. You know, like Eclipse, ROR, Purosol. I've got the polymer. I've got isopropyl alcohol and other stuff. So you know, the polymer works for a split second, but then it leaves static electricity and I'm in an apartment. So until I get a clean hood, a dust-free clean hood, the polymer doesn't really help me. So like I'm back, like a lot of times just using Kleenex tissues, Trusted Care Kleenex only. That's the name of it. You don't get any of the other ones. That works with isopropyl alcohol 100%, or the Clips solution, which I guess is methanol with the PEC pads. That works. Also shown are the 3 black paints, Black 3.0, Musso Black, and Black 2.0 on the left. And then on the far right, you see Tangle Trap sticky coating. That's stuff you stick on trees to keep insects from climbing up your tree and killing it. You put that on the inside of your dew shield, and as the dust makes its way back down along dew shield, it'll tend to get attracted to the sticky coating and not go on your objective lens. And I always bring 2 objective lenses so that when one gets dusty, I can switch to the other. You can't really clean it in the field. It takes like an hour to clean one lens. Generally what you do is you clean it and it didn't work, and you clean it and it didn't work. Like it leaves a film or dust got on it or something. And so you kind of trial and error. Eventually I'll have to buy new lenses. This we don't have to go through, but this is, I had kept, I don't know why I even showing this slide. It's a list of like all my real attempts to see the corona. There's not that many considering how long ago I built the thing. I'm not counting all the times like in front of my house I tried it and it was ridiculous, or I was like on vacation and it didn't work. But it's all the real attempts. And I'll show you pictures of these. The important ones I'll be going through. But yeah, I'll be going through the important ones. So let's take a look instead of reading. So this is not the corona. This is what my first coronagraph looked like using an iPhone, because I didn't own a camera yet. And what you see around that, so the black circle in the middle is my cone blocking the photosphere, and then the green around it is my 5303 angstrom filter. And around that black thing, you can see some things sticking out, and they're all artifacts. How do you know that? You shut off your oven heater, the temperature drops 20 degrees Celsius, or at least 12 Celsius is enough. The filter is now off band. If the signal doesn't disappear, then you know it's not the corona. There's other ways of telling, like you can also rotate the thing and see if it rotates with the scope or rotates with the sun and so on. So that's all artifact. Here's my first view of the corona on 9/11/2021. On the left is, again, the iPhone shot. On the right is the satellite image taken at the exact same, almost the exact same time. It's 171 angstroms because I didn't know that it was 211 was the better frequency yet, but it's close enough. So the thing at 2 o'clock that's marked artifact is an artifact, but the stuff below is actually the corona. I don't know why I marked the middle arrow down there, but the 2 on the side match the active regions on the right. But the more important thing is when I shut off the oven, they disappeared. Then I turned on the oven and they came back, and then I shut off the oven and they disappeared again. And I also rotated it, and it's rotated and it stayed with the sun. So I did a lot of work to make sure that this was really the corona, not an artifact. By a month later, I was better at it, and now you can clearly see it getting better. If you look at the SDO image, now is at 193 versus my green one. Actually, the one that was visual is the one that's marked visual on the left. That's the one I saw in the eyepiece, and then I took the picture. And then I didn't really look at it, and I sent it off to Klaus, like without thinking. He's like, and I'm saying, I think I saw the corona, and I'm describing it's the thing at 11 o'clock. He's like, well, at 1 o'clock, you've got the corona right there. What are you talking about? And I'm like, and then I look at the thing. Oh my God, I caught the corona. So then I look at the SDO image, and of course, yes, the big active region was under the one that I didn't notice. I think I didn't notice it because on the far right, you see a lot of artifact. So I was like ignoring everything to the right because I knew I was going to get fooled by it. So I was focusing on the thing on the left, but that thing on the left was visible in the eyepiece very easily. Again, went on and off as I turned on and off the oven. Then I got that was with one of those. That's at 2 angstrom with filter. Now this is with a 2 filters, double stack. So we each got our second filter from. We got one first, and then we got the second one from the company. Andover. And now you can see now the artifacts are starting to disappear, and you're getting a better view, and it's pretty well matching the image that the active regions are wherever. And actually, I can see the shape a little better, and the shape is starting to match. So this is a month later. So this is 1 month, a month, another month, another month. And I'm getting a better job here. This is at 171 angstroms on the right at the satellite image. So then I build a new coronagraph, right? I scrap the Botter one with all those aberrations. Well, I had already replaced the field lens, but I had other problems too. And so this is my new one. That's the one you just saw the picture of. And it's shown here. Now I'm getting real images of the corona. So now it's like, okay, this thing is working. And I don't need to like turn the filter on and off to see if it's really the corona. It's just obvious. You look through the thing and there's the corona sitting there with streamers. So you can see, and this was probably this may have been my, I have to look back at my list. I think this was my first like, oh my God, this thing really works. This is at Otsiantha Mountain. And you can see the streamers lining up, but I'll show you more detail in a moment. And then this is at Black Forest Star Party that year. So this is a year ago. And this time you could see the streamers better and the loops and stuff. So I was kind of proud that I was able to pull in the loop. So it's getting better. On the left side of the image, you start seeing the fringes. I'm going to show you that's one of my bane, which I've talked about online. There's a couple of aberrations, actually. You know, there's those reflections that light, the circular light around the black circle. So like, I just haven't worried about it that much, but the fringes are really kind of killing me and really limit how much I can see. In fact, this is from Otsiantha Mountain without doing any subtraction. I'm going to describe subtraction in a minute. So it's like I can see the coronas there, I can see the streamers, but I've got this annoying fringe pattern. The fringe pattern is not a reflection with the camera. It's not even a reflection between the two filters. This happens even with a single filter. It's internal to the filter. And I get two of them in a cross pattern because I have two filters. One of them seems worse than the other for some reason. Here's the fringes accentuated. So what I do to solve this for now is I reduce the temperature of the oven by 12 degrees Celsius. Pointing the scope away, forget that. That doesn't work. But I reduce the temperature by 12 degrees Celsius. And that creates a flat, and then I subtract the two to get rid of it. Unfortunately, it doesn't work that easily because when you reduce the temperature of the filter by 12 Celsius, you shift the fringes. So you can't just do a simple subtraction. So instead, you'll see what I do. All right, I'll come back to that. I jumped to this for some reason. Okay, so here, this was my first image that I felt like I really had a circumsolar corona, like the corona's everywhere around the sun, and it well matches the SDO image. By now, I learned to do 211 angstroms was the best match. So it's pretty good. And every little, like if I went through this and went through all the faint things, other than the fringes that I can see, they're not that bad here, but I can see them. It matches every little detail on the other side. The only thing missing is they're blocked by the prominences, but I don't see the prominences. So I can actually see things they can't see because they can't look through a prominence. Here's the Lijiang University coronagraph image for the same day. And that's kind of, I can turn it around and process it. So that's what they're producing. But I think their scientific mission is something that for this image is perfect for it and not my image. So like, who's to compare? So this is the actual image coming out of, well, it's stacked. So this is what I get out of my camera after stacking, just so you can see it. So that's the level of background light. And you can see at 11 o'clock and 4 o'clock, you can see the corona on the left image. On the right image, the corona is gone because that's the one that's 12 degrees Celsius lower. You don't see any fringes because the fringes only come out when I start boosting the contrast. So I subtract these two guys using Photoshop. It's changed over time, but more or less what you need to do is break your image into regions and shift the regions over so that the ripples of the fringe line up again. And you can't just shift it one way, otherwise the photosphere, the cone goes into your image. So you got to shift one way and one the other way. But if you do that, it doesn't quite work. So this one I broke it into, now I don't do 7 anymore, but I do at least 2 and sometimes 4. So what I do, ASI capture, I use ASI capture because I have a Mac and it's easy and it works. Then I use Astro Surface to stack the image, but I don't do wavelet compression, wavelet processing anymore. I skip that. I don't do any wavelet stuff anymore. I just do a little bit of unsharp masking at the very end. And as I write there, I break into flat into 7 regions. I set levels, I mask. Oh, I do radial. I'll show you that. So here's the best I can do on the left without the flat, without that subtraction. On the right is what I can do with the flat. So subtracting out those fringes does help. If I try to make the left one look any better, I just see a fringe pattern, which is very ugly. Here's how my gradient helps me. The corona is much brighter in the center than as you go out. And so if you subtract a radial gradient, I find I can do the, it's basically just another form of what is it called? High dynamic range processing. I just subtract a radial gradient and get the one on the right. This was this summer, actually, because I'd never gotten an image from Connecticut before. So this is only 1,000 feet in the air now. And you can see the one on the left. So it's it's not as good as my mountain images, but it was pretty good. I was pretty proud of this, getting this one done. And then this was Black Forest Star Party that I recently posted. This is the one that I posted that I had you guys vote on which one you like best. And so this one, it depends on whether you're like in PowerPoint or posting the image. It changes like how the computer does the dynamic range. So which one is best. But I kind of like this shot is one of my favorites because it had a lot of detail on the streamers and loops, but still was circumsolar. So I like this. I still want to get a better image, but this was like one of my best. Then the partial eclipse, the annular eclipse of the sun came. So I went to Comb Ridge, which is in southeast Utah. You see that yellow bag sitting on the ground over there in the desert. So that's how I had to carry this thing on the airplane by myself. So I broke it into parts and carried it in that duffel bag and a carry-on bag. But I got the coronagraph to Utah, and I wanted to see if I could capture the moon before first contact, so before the eclipse. Funny thing is that my iPhone powered down because it kept trying to connect all night in the cold weather, and my watch for some reason slowed down. So I was off by 15 minutes, and I almost missed the eclipse because I'm trying to get it before the eclipse starts, and I started 15 minutes later, but I just made it. So my first image was already useful. I was aiming to start 15 minutes before that. But here's the image, and the white arrows highlight a little bit. So the first image at 14:55 Universal Time is the first one I could see the moon. It's 15 minutes before first contact. And then I don't know if you can see it on your screens because it may be hard to see, but I can see it there. And then 14:57, 59, 15:03, 06, 08, becoming more and more obvious. 15:10 was first contact. And then 15:11, you see it's overlapping. So now you can see it in eyeglasses. So that was fun because I don't think people have seen that for a while by looking at SDO before an eclipse. So it's not new in that sense, but amateurs haven't taken the image before. Then I said, well, when is the sun going to be behind the Empire State Building? And so there are two times of year, and happen to be basically October, November, or April are the two times it's at the right height to get it. And so I went on the New York City subways. It took 10 elevators worth of carrying that stuff I showed you. That is West 34th Street and 12th Avenue. 12th Avenue is the river in New York City. So you see the water behind me, and then in front of me is the Empire State Building. Now, it's hard to find there's so many tall buildings, but I got this, and I knew that I had a small field of view. So the fact that that building's in front of the Empire State Building in that image wasn't a problem because I wasn't going to be seeing any more than that anyway. Let's see. Oh, that thing on the left. That's the thing on the left is what I got up and down. So that's what my coronagraph fits in with its mount. On the right, my friend Stan Honda took this picture of me taking a picture. He had an eclipse viewer with him. So what he cleverly did while he was taking my picture is he put the eclipse viewer inside his field of view. So what you're seeing there, that yellow thing in the black rectangle is the sun behind the Empire State Building. While I'm taking my picture, he's taking a picture of the sun behind the Empire State Building in the same frame. So that was kind of fun. And then here's the image. On the right is that image of the Empire State Building. I think the one I showed you before, it's just in black and white because there's no sense in introducing color here. And I got the circle of the Empire State Building, that's the 102nd floor observation deck. So if you pay extra money, 86th floor is where you normally go. If you pay extra, you get to go to the 102nd floor. So that's the observation deck. And you see, I have all the images as the sun goes all the way across. I like this one best. So this is, remember, the circle is the eclipse induced by my coronagraph. You see the Empire State Building. And then you see the coronal streamers. I should have included the image. this was not a perfect day. So I'm at sea level. You know, I'm at sea level because there's the sea right behind me. So I'm like 10 feet above sea level and in a big city. And the day was pretty clear, but not perfect, because I have an image of that day and I have an image of a day 2 weeks early where it was nearly perfect. I wish I could have gone that day. And that's why this image has a lot of background light. That's light in the atmosphere. And the bright light on the right, that's light refracted through the 102nd floor windows coming around. There's 2 panes of glass at an angle. So it gets refracted into my camera. But you can see the coronal streamers. And so the fun thing for that is that, you know, the Empire State Building missed the 1925 total solar eclipse in Manhattan. It missed it by 60 blocks. So literally it was just south of the totality. It was also 6 years too late. So 60 blocks in 6 years. But it turns out in 2079, which I won't be here for, there'll be another eclipse over New York City, which you can see it. But it's in the first minutes of the day. It's at sunrise. Okay. Then you can also look at prominences in the coronagraph. Like, why not use it like everyone else does as a prominenceograph? So you can get, the one benefit is you can get very faint prominences that I can't get in my H alpha filters, but I only have 50 millimeters of aperture, so my resolution is not that great. You can get other wavelengths though. So I can get like hydrogen alpha. Actually, I can get it at 10 angstroms. Like you can get, well, I'll show you in a second. You don't really need a filter. I can get H beta. I can get H gamma. I've got helium D3 is very easy to see. H gamma is hard. You have to have a good day to see it. Helium D3 is easy. And then you can see prominences in their natural color. So here's my first picture of a prominence. You probably can't see this, but I on my monitor right here, on my big monitor, I can see pink in that green field. I don't mean the pink ring. I can see a pink thing heading downward. You probably can't see it, but hold on. This was taken more recently, and the inset, you see the pink prominence coming over the edge. It actually looked much better in the eyepiece because where it's white there, it wasn't really that bright. It was overexposed to my iPhone because it was trying to get a picture of the background, but the prominence, I could see more of it. But it was like that pinkish color where you're getting all the frequencies of the prominence. Of the main image, you can see that it was a pretty blue sky. So this is Pikes Peak in Colorado. So after the eclipse in Utah, we went to Pikes Peak on the way to the airport to go home and stopped and took these pictures. I was hoping to see the K corona, but I didn't. It was a hazy day. Pikes Peak is very clear on a hazy day, but it's still not as good as a clear day on Pikes Peak. So I didn't get the K corona. I'll have to try again. But I did get this. So this is, well, I'll talk about eye safety in a minute. And then actually I'm almost done. So 2 more slides. And then just to show, these are my H alpha setups because I'm talking, I won't be talking again probably. So I figured, so my favorite right now is my double stack LS80 Etalons in my 6-inch AP 155 refractor with a B 1800 blocker, which has been which is a good block. It's, yeah, you know, I paid whatever. So we've iterated on different blockers. This is a very nice blocker. So that's my favorite. It gives a beautiful view. It's not full disc. I would have needed to go for the LS100 or bigger, but this LS80 is nice and portable, and it was affordable, and it produces just a gorgeous image that I really like. The second one, that's my C11 with an 11-inch Aries ERF. And I'm there using my Solar Spectrum 0.3 angstrom RG research grade 32 millimeter. That one's currently in the shop, so I can't show you that one much anymore. So waiting for Mark to fix that. Third image, that's a Quark on my 155 before I did all this other stuff. And my LS80 DS2, that LS80 is different than the other LS80. Those are 2 different LS80s. And then also I have a Lund Calcium B1200 with a PST #1 yellow filter double stacked on it. So I use a double stacked filter. I didn't get lucky to get one of those other fun filters that people have gotten. And then my best white light view I've ever gotten is with a 10-inch Zambuto teleport with a Botter film on it. And that was really fun. That was, one day I was looking at it and I had that seeing was limited. Daytime seeing was 10-inch limited, like literally full resolution. And the umbra looked amazing. of the sunspots at white. So this is not H alpha, I guess I should admit it, H alpha or white light. And I saw such detail on it and not just light bridges. So then I talked to Marty and said, are you getting, I didn't see it on any professional images. And then now you can, because with the newest ones. So Marty reprocessed his images and we got those details out. But normally you don't get it because the dynamic range isn't big enough. So there's stuff you can see. Visual is not dead. Sometimes you find something that no one's noticed because they haven't processed on that end of the spectrum or that end of the dynamic range or whatever. And then lastly, eye safety. You know, I have 30 years of building solar stuff. I've talked with Ralph Chow, who wrote the ISO standard for, you know, visual eye safety, for, you know, naked eye safety and everything. And I still have mistakes, and you know, there's a lot of stuff you need to do. So I warn people, like, don't go, because some of that, you know, this is obviously, you know, that's a dangerous thing to do. So you don't want to do that too lightly. And you're not, there's a couple, you know, you can put an ND1 filter in there that blocks it by 10 times. It's F30. There's a bunch of calculations. So I don't want to describe it too much. There's a bunch of, and you can put in a UV-IR blocker. So there's a whole bunch of things you do stack to make sure you don't blind yourself in the process. I don't go into too much detail online because I don't want someone like misinterpreting and doing it wrong. So I try online just to say, I'll tell you how to do imaging. And I'm pretty sure, actually, this is unfiltered right here. This is literally no filter, okay? I had my ASI 1600 camera. I realized that with the F30 thing, it wasn't going to hurt my camera. So I let that, when the sun peaked out, it was fine. In fact, I could actually, at 33 microseconds with zero gain, I was unsaturated with the sun coming through the telescope. So there's enough attenuation in various forms that I could talk about that I'm actually can actually get an image of the sun that's not pinned when the photosphere is coming through the scope. And then you put a, you know, bunch of stuff on it. So you can kind of get there, but you got to know what you're doing. Anyway, I will stop there.
Wow, thanks, George. Your enthusiasm is just infectious. It's just wonderful to see all that you've done. It's absolutely incredible. So has anybody got any questions for George?
Just a quick one, George. First of all, that really was excellent. Thank you for that. So at aphelion, perihelion, obviously the sun diameter is bigger and smaller. What effect does that have on your equipment? Do you have to make adjustments for that?
Oh, for the sun changing diameter?
Yeah.
Yeah, only the cones. So the Botter prominence viewer comes with a set of 6 cones, and that's good enough. Generally for the corona, you're going to use a little wider cone than you are for prominences. So I lean on the wider side because the prominences are very interesting right up to the, you know, the spicules and everything. So you're really trying to get close. Whereas for the corona, it's not that different, you know, an arc minute either way. So, well, arc minute either way. So you want a little bit bigger, and that'll reduce the amount of diffraction, you know, around the cones. You get a little bit better, a little bit that when if you notice there was a black circle with a white ring around it, as the black circle gets bigger, the white ring gets dimmer, and it just it's a little easier to do it helps the processing a little bit. So I'll go for a little bit bigger cones. So you don't have to be quite as precise as you would if you were doing prominence imaging. So I go from like 9.2 for summertime to 9.5. Actually, I never get to 9.2 because I'm going bigger. So I'm probably at 9.3, 9.4 in summertime, up to 9.5 at wintertime.
Okay. Thank you.
Well, George, thank you for the wonderful presentation, man. I really appreciate it. And I think we may have spoken at NEAF a couple times in the past.
Yes.
And I remember. And that's just a lot of information, man. I'm still kind of trying to absorb a lot of that. And making your own stuff is not dead, clearly, because nobody's going to market that to consumers because no one would have any idea what you were talking about if you tried to market that.
That includes me.
Yeah. So I'm still absorbing that. And I can't tell you how many times I'm frustrated on Facebook or social media, because that's where I spend a lot of my time running a nonprofit, at every new solar imager comes out and they always call everything a coronal mass ejection. Everything coming off the side of the sun is a CME. And then, if you try to, part of our nonprofit is to try to put out correct information. And if you go in there and you say, this is not really a coronal mass ejection, this is a prominence, you're looking at the chromosphere and not the corona. All of a sudden, you're the asshole and everybody thinks you're just bothering people, etc. So that's one of my pet peeves, is to hear people call everything a CME. So I'm guessing you've heard that a million times yourself or read that.
Yeah, it's hard to, yeah. I mean, getting the concept across to people has been hard. And then, yeah, like why, like doing the Empire State Building is fun for me. A lot of people like completely don't get like, what was the point? Like, what are you doing? Why did you do that? But that was good for me because I know I'll never see a total eclipse behind the Empire State Building. So that was my opportunity to do it. But even getting like the sun approaching the moon, the moon approach, well, however you want to look at it, but the moon approaching the sun during the eclipse was hard to explain to people. Plus, it's subtle to see. That was with me doing image processing to get it there. Could we make a commercial? Like Klaus thinks no, because there's just too much tweaking to get it perfect, and that it would just be a lot of frustrated customers. It could be made to be safe, though, because the 5303 filters cut so much light, you can stare directly at the sun through them. Like you can set it up so that it's safe for the eye. So you don't have to worry about blinding people when it comes out from behind the cone. Actually, like 10 times dimmer than the Bader prominence viewer when the sun comes out from behind the cone in their 10 angstrom hydrogen alpha filter, which you really shouldn't have been doing, but whatever, it's close enough. So it can be made safe, but a single piece of, like, if your objective lens has a single piece of dust on it, like you can see the dust, like you look at the lens and like, oh, there's a piece of dust there. The kind of dust that you'd say that looks so clean for nighttime, that's enough to obliterate the corona on the other side. I remember one whole session was ruined because some bug had put a gossamer thread across the front of the scope. So I got the main image, and then when I did the negatives, the subtractions, the bug had gone across somewhere between those two. And so then the session, I couldn't do any subtractions. It just turned the whole thing white. And you couldn't see the thread with your eye because it was so thin. It's just when I was putting the scope away, there was a glint of light from sunlight reflected off the thread into my eye. And I'm like, oh my God, that's what happened.
Right. It's always something. Well,
So
thank you again
not a good product.
for taking the time to show us all that, man. That's an incredible feat you've accomplished there. Christian, welcome to the forum. I don't think we've ever met, but I've long admired your work, and thank you for joining us. Who else wants to, who's going to start talking about these gigantic prominences over the last 3 days?
They are incredible, aren't they?
Yeah, amazing. 2 days in a row, prominence of 300,000 miles in length. Of course, both days were cloudy here in Atlanta, but
cloudy here too. So
everybody's clouded out. We're drowning as well.
Awesome. So, Alexandra, what else do you got for us?
I just wanted to say to George, I've got the Bader prominence filter set, and I've always admired what you do, and I've looked at prominences with it, and they're really lovely, but it took a lot of tinkering and help from a chap in Germany to get it to actually work, because when I inherited it, the hydrogen alpha filter was just absolutely dire, and the chap from Germany took it and reconditioned it, gave me a new hydrogen alpha filter, and yes, now I can see the prominences beautifully, but I am not sure whether I would have the technical ability at all to try and see the corona with it. I'd love to. It'd be absolutely fantastic. I just wish I was clever enough, to be able to, but I just can't. I looked at all of your, like your calculation, your mathematics, and I thought, oh my God, there's no chance for me.
Well, I think so. If I had bought and you have a working one that doesn't have a different lens, so what you would need to do, literally, now I kind of have some experience. So what you would need to do is the section that goes before the cone, I'd paint that blacker than it is now. So that's just a matter of buying paint and painting it. You'd need to put a field stop on it, because that made the biggest difference, was putting in one extra thing that actually I emailed with Wolfgang when I was like 2 years ago when I was doing this, but it wasn't much he could do for me from there. You'd have to create that one of those rings of black, and then you'd have to buy the 2 filters. So those filters cost $2,000. So it'd be like a big invest for the pair, or $1,800 is what I paid. So
that's nothing for Alexandra.
Yeah, good.
Not at the moment.
So that's the expensive part. Klaus did it at first with filters he got for very cheap, but he had to tilt them. And that's why his early images that Klaus had, remember, were only for one direction, because when you tilt it, you have to, only a piece of the sun comes on band. That's why we ordered these filters. It just so happens a very common laser wavelength is 532. And we need 530, so it's close enough he could tilt the filter and get there, but it's not as good an image as getting the real one.
Well, George, we have a few traditions here at the Solarchat Forum. We're all friends, and we just have fun mostly. So what do you do for a living? I'm just curious. Are you a brain surgeon?
I am not a brain surgeon. I do work for Columbia, and I do teach about computers and medicine. So I do research in computers and medicine.
Okay, so very good. Are you an MD as well, or?
Yeah. I teach PhD students. So I used to do computers as my hobby, and then it became my job. And so I was like, well, I'm not going to do both. So I said, well, I used to always be so into astronomy. So like in the late 1980s, it was like, I got to get back to astronomy. And so then since then, I've really been working hard at it as my hobby.
Well, that's great. Now the fluff's out of the way. Let's get to the meat. Who is your favorite Star Trek character and why?
Well, I mean,
Christian, you're next, by the way.
Bad character, or could be member of the
your favorite character and why? Series. Take your time.
Well, that's a tough one. When I worked I was an intern at IBM for a while, and we used to play Star Trek episodes. Like every day for lunch was Star Trek. That was like 10 years after the series started. No, 15 years after the series stopped. I mean, I'm going for Kirk, because like, why not? Like all these years I would avoid saying Kirk, right? Because you got to be modest and but why not? It's a series about some guy saving the world. Why not go after the guy who's not saving the world. I'm sorry, that's too small. Saving the universe over and over every week. Yeah. And he's actually a very nice person. So I have a friend who lives in California, who lived in Irvine, California, and their grandsons were both in the same school. And he'd come over for like a party, and he's like just an approachable, nice person. Despite all the stories you read about him not getting along with anybody on set, he's actually just like this incredibly nice person.
Very good. I've got a lot of respect for that answer, because everybody does love Kirk, and if you say you like Kirk, you're all of a sudden a self-absorbed, grandiose, person who wants to lead everyone. But everyone does love Kirk.
You're a 10-plated overbearing dictator with delusions of godhood.
That's exactly right. Okay, thank you for that answer. And Christian, what is your favorite Star Trek character and why? I think you're still.
Problem. Do you hear me?
Yes.
Yep.
Yeah. Well, I'm sorry. I don't watch a lot of Star Trek. I'm not a big fan.
Strike one.
Sorry. I'm sorry.
Oh my goodness. Well, I appreciate the attempt. Of course, my favorite character is Mr. Spock, because Mr. Spock is logical. And I've been in the military, and I've been in a submarine, and I've been in very, very high-tech pressurized situations. And I never wanted to be the captain. I always wanted to be the scientist. And Mr. Spock's my favorite. And, every horror movie and every disaster movie ever made, everybody doubts the word of the scientist at the beginning, and everything goes to hell after that. So I've always wanted to be the scientist. So next month's meeting will be the second Sunday of the month, as usual, at 1800 GMT. and I really hope everybody comes back. Does anyone have anything they'd like to add about this month's sun and how freaking incredible it is every time you look at it and how it's changed your life? Or who has any comments or anything about the forum? I don't know if you noticed, but we started a new forum just for the Solex spectroheliograph. I think that's really taken off now. And I'm happy for it because the entire hobby is about spectroscopy, and trying to spread spectroscopy to the average American citizen is pretty much impossible. And that's what our nonprofit's all about too, teaching about spectroscopy. But we have to do an indirect route to have some sort of pretty picture for people to look at to get interested. But really, spectroscopy is where everything is in this hobby. So I'm really glad to see that a spectroheliograph is taking off. And we've got our own little forum created for those posts. So does anyone have any comments now about what's going on in their solar astronomy lives?
Well, I've got to say, with me fixing to move and everything, it gives me something that's regular to do because my life has been hectic, really bad lately. Moving from here to South Carolina and with my dad's ailing health and stuff like that, it gives me some kind of ritual to fall on. It helps.
I totally agree.
Something regular.
I totally agree. I had a guy, Raymond Lalonde. Some of you may know him. He's a Canadian solar astronomer who came up to me at NEAF about 10 years ago and said that his wife had been terminally ill for several years, and she'd been very ill and then died. And he said he found our forum and started doing a little PST solar work in the backyard. And he said he credits that with saving his life, man, because he was such a sad and grieving situation. He could go out and look at the sun and just see, like we all get out of it, to realize we're not that important and the universe is beautiful and gigantic and we are a tiny, tiny, tiny little piece of it. And a little bit of humility goes a long way. We could use a lot more of that here in the United States. Nick, what's going on over in Nick Spencer world?
Just admiring Stuart's tree, if I'm absolutely honest.
It is a beautiful Christmas tree.
Yeah.
Oh, he's turned the video off. Oh, there he is.
I was trying to unmute myself and missed.
It's like everyone in the UK. It's just really cloudy and the rain and mist and everything. So it's all online for us, I think, at the minute. Great presentation. So fascinating. Thank you.
Agreed.
Yeah,
Sean,
agreed. Me too. Unfortunately, guys, thanks, George and Alexandra. Stephen, I'll catch all you people later. I need to go
sir.
to work.
See you later, Ralph.
Bye-bye.
And for those of you that didn't understand anything that James Parton said, I want you to know that I understand every single word of it perfectly. He's got the strongest accent in the forum. And there he is. James and Sean and I all live in the southern United States. So Christian's tiny, almost imperceptible accent to his English was nothing compared to what you get in South Carolina and Georgia. Is that right, Sean?
No, that's right. If you want a thicker accent, I'll bring my mom to the next call. She's from Central Alabama.
Oh boy! All right, then. Well, Natalie and I are down here at the marsh on the Atlantic Ocean on the Georgia coast, and it's 75 degrees and beautiful. It was perfect every day this week until about 2 hours before the meeting, and then of course it clouded over. But next month again, I'm going to try and set up the big giant H-alpha scopes I have here and try to give us some live viewing. And I really hope we get some giant prominences lifting off again. And I want to say thanks to everybody. Hey, Rob Lane, I haven't seen you in too long, man. You need to get back here to Atlanta and come see us.
Yeah, definitely will. Definitely will, early next year.
And if you're not on our Facebook group, we really keep it clean over there. We don't allow any, stupidity. We don't publish any APODs. That's another story. But
I've seen your comments on iPads. I agree with you.
Yes, I look forward to seeing those. But if no one's got any more comments, we record every meeting and we put it in the Solarchat forum with the date. Alexandra, who along with Mark Townley maintains everything to do with the forum, we are very grateful for you, ma'am. You are the backbone of our entire nonprofit. And Bob, you have something?
Yeah, hi, and I want to say thanks to George. It was a wonderful presentation, and it's nice to see you in person. And for Alexandra, unfortunately, she's had to leave. But I was thinking one of the neatest things about prominence device would be if you could make a filter that let both H alpha and H beta through, so that you would see those pink prominences like you do during a solar eclipse. And I was wondering if you might have any thoughts on the feasibility of making a dual band H alpha, H beta filter, given you've had to deal with getting a custom filter essentially made.
They can certainly do it. I don't know what the development costs would be. Klaus was thinking of different solutions which were more mechanical, how to join the light from two filters, but they can just produce a filter that has two spots, because they obviously have for, you know, nighttime astronomy, they've produced that, such a thing. Mm-hmm. So they can do it. And you don't need, since it's a prominence viewer, you don't need a, you know, a 0.7 angstrom filter. Like I'm, you know, a 10 angstrom filter works fine in my, in the bottom prominence viewer without modifications. So I think it shouldn't be that hard to get a dual 1 nanometer. Well, 1 nanometer is tight. I don't know. I think it is possible, but like that's not just calling up Andover and say, give me a filter at this frequency. That's like talking out to their design engineers, and now you're talking like real money. If you're not selling it broadly, but it would be neat. Klaus, I guess Klaus didn't make it. He's in Germany right now.
Well, there were a couple guys that tried to get in that had names that I did not recognize that were also in Russian characters, and so that we didn't have another episode of people drawing large penises on the screen. I did not let them in.
Okay,
but I don't think one was Klaus.
Okay, well, so I could check with him, and I'll ask him what his idea was, and whether it's feasible. It was probably something reflecting off. Maybe it was, you know, one of those things you come off, go back, the two ways of going in. Because with the prominence viewer, you're allowed a little bit of slop there. I'll ask him. It's so nice to talk to you, Bob, by the way.
Oh, yeah, I know. One time Lunt did there, and Steve, I think, got this, was an 8-inch beam splitter reflector that had both a calcium K-line and an H alpha capability, using a beam splitter. And I don't know if you could use a beam combiner with an H alpha and then an separate H beta filter to get you again that dual band image. But I'm just thinking out loud here.
I think that's what Klaus was thinking of. That's precisely what he was thinking of.
Okay, cool. All right. Well, thanks again. It was wonderful talk.
When is that setup going to be available at Woodland Hills Camera and Telescope?
Yeah, really.
Because I'll take 3 of them. Yeah. So again, we do record all these, and thank you everyone for attending, and feel free to message me if you want on Facebook or whatever, if you want some changes on the forum or on the Solarchat forum. And everything's going good here, and I want to wish everybody a happy holiday season and stay safe, and let you know how important everybody here is to me and to spreading the science of the sun. So thank you everyone, and we will see you next month.
Thank you.
Thank you.
Thank
Thank you,
you.
Guys.
Cheers.
Bye.
Bye.